I'm going to go through these problems so you guys can check yourself, see if you did anything wrong, kind of correct any thinking. So if you hear any stray noises like that, that's my dog. I have two and they're whiny. Okay, so Janice drives her scooter 7 kilometers north. She stops for lunch and then drives 5 kilometers south. What distance did she cover and what was her displacement? So I like to go through the question, kind of pick it apart, underline things. I think it helps sort. So in this case, and then actually all these questions, we're looking for 2 answers. So we're looking for distance and we're looking for displacement. So I'm going to start by drawing a diagram, and you guys should too, to keep everything in your mind organized and kind of get a visual, especially when it comes to displacement. So 7 kilometers north, and turned around and went 5 kilometers south. So for distance, we're doing total distance, right? So we're adding the 7 kilometers plus the 5 kilometers. So that's 12. Now displacement, remember, displacement is the difference between the starting point and the finishing point. So we started here and we finished here. So I'm going to take my 7 kilometers and subtract 5 kilometers. And so I'm going to get 2 kilometers, and I'm going to put my direction, which is north. And I'm putting it in brackets because we haven't gotten to forces yet, but forces are measured in newtons, and newtons is a capital N. So just get used to putting your directions in brackets. Okay? So got 12 kilometers for the distance and 2 kilometers for the displacement. Number 2, Anthony walks to a pizza place for lunch. He walked 1 kilometer east, then 1 kilometer south, and then 1 kilometer west. What distance did he cover and what was his displacement? So start with my east. Kilometer east, 1 kilometer south, 1 kilometer west. Okay, so for distance, again, we're just doing our total distance that he walked. So we know he walked the 1 kilometer east, 1 kilometer south, and 1 kilometer west. So that's going to be 3 kilometers. And remember, distance is scalar, so we're just looking for a number with our units. Don't forget your units. And no direction. Okay, so for displacement, we started here and we ended here. So this distance right here is our displacement. So I know because this arrow is the same as this arrow, I know that the displacement (1 kilometer south). So essentially, I mean, if you think about it, like this arrow that went east and this arrow that went west, when it comes to displacement, those canceled each other out because they went opposite directions. But the south, we didn't go north, so we did not cancel it out, so we just have the 1 kilometer south. On his fishing trip, Justin rides in a boat 12 kilometers south. The fish aren't biting, so they go 4 kilometers west, then follow a school of fish 12 kilometers north. What distance did they cover? What was their displacement? Okay, so start with drawing my diagram. I'm going to go 12 kilometers south. 4 kilometers west. Oh, that's east. Goofy. Try this again. South. West is to the left. Never eat soggy waffles. One day I'll learn my directions. Okay, 4 kilometers west. And then 12 kilometers north. So total distance, I'm looking for this total amount that was traveled, right? So I'm just going to start abbreviating distance. 12 kilometers plus 4 kilometers plus 12. 28. Okay, for displacement, I started out here and it ended up here. This arrow that went south and this arrow that went north cancel each other out, so the only direction I have is this. So this is the displacement from here to here. That's why it's important to graph. You can just look at it. It's similar to the to question number 2. So I know that my displacement, remember displacement is basically how far did you actually move from your starting point. Doesn't matter how far we actually walked. We ended up only 4 kilometers west of our initial point. Okay. Move this out of my way. All right. Camel. Tara goes on a camel safari in Africa. She travels 5 kilometers north, then 3 kilometers east, then 5 kilometers south. What distance did she cover? What was her displacement? So I saw a lot of you guys were only doing one answer, so make sure for all 6 of these that you had 2 answers. Because distance and displacement are not going to be the same unless we traveled, you know, only away from our initial point and never went back towards it. Okay, so let's see. 5 kilometers north, 3 kilometers east, and 5 kilometers south. So, same as these other problems, these are all pretty similar. So this was our initial, this is our endpoint. And you can tell which direction they actually traveled by the arrows. This is a vector, this is our directional arrows, right? So remember distance, you know, we went 5 kilometers plus 3 kilometers plus 5 kilometers. So distance was 13 kilometers. No direction needed. Okay, and then if we're looking at this graph, we can see if this was our start point and this was our final point, this arrow right here shows you our displacement. So I know that that is the same as this top one right here. So displacement is 3 kilometers east. Okay. Alex goes cruising on his dirt bike. He rides, oh, this is the one with the longest distances. Okay. He rides 700 meters north, 300 meters east, 400 meters north, 600 meters west, 1200 meters south, 300 meters east, and finally 100 meters north. What distance did he cover and what was his displacement? Okay, so I'm gonna try my best to get this right the first time. So let's see. What? 700 meters. And then 300 meters. Another 400 north. 600 west, so I'm going to go about double what my east was. 600, this is obviously not to scale. Let's see, 1200 meters south. $300 meters east, and then 100 meters north. Okay, so started here and also ended here, right? We went all that way, but we ended up in the same spot. So that makes our displacement easy. So I'm going to go ahead and write my displacement is 0. Okay, my distance, that one's a little bit longer, so 700 meters plus 300 plus 100 plus 600 plus 1200 plus 300 plus 100. Get my calculator out. Looks like it's 3,600 meters. Number 6. Travels 3 kilometers south and then 4 kilometers east. How far does he need to go to get back where he started if he takes the shortest route back? Okay, so So, started here, ended here. We're looking for the shortest route back, which is this way, right? The hypotenuse is always shorter because we're not going to go the full, the distance here is 7 kilometers that he went, but we're looking for the shortest route back, which means we are looking for displacement, right? So we need to find this hypotenuse. Remember Pythagorean theorem. Or if you remember the shortcut, you already know the answer. So 3 squared plus 4 squared equals c squared. Got 9. 16. C equals square root of 25. So displacement is 5 kilometers. And do not forget your distance. You have to go north and then west, northwest. So the distance was northwest. So you guys can either remember Pythag or remember the shortcut. If one side is 3, one side is 4, the hypotenuse is 5. All right, moving on to speed problems. We have our equation right here. Speed equals distance over time. The football field is 100 meters long. If it takes a person 20 seconds to run its length, how fast were they running? So we know we are looking for speed. We have our distance is 100 meters, and our time equals 20 seconds. Now I'm looking at this question. I don't see it asking for a specific amount of units. So I can just plug and play there. So I've got 100 meters divided by 20 seconds. And like I've shown you guys, if you draw it like this, it makes your units a lot easier to kind of visualize. So I know my units is meters per second, and this is my answer. So speed equals 5 meters per second. Moving on along. Okay, the pitcher's mound in baseball is 85 meters from the plate. It takes 4 seconds for a pitch to reach the plate. How fast is the pitch? So we're again looking for speed. So we know we're looking for speed. We have the distance, which is 85 meters, and the time, which is 4 seconds. So speed equals distance over time. Speed equals 85 meters for 4 seconds. Slash that, right? So speed equals 21.25 meters per second. So that baseball is moving 21.25 meters every second. And it's not accelerating. If you drive at 100 kilometers per hour for 6 hours, how far will you go? So we're looking for a distance. How far will we go? Distance. We know the time is 6 hours. And we know the speed is 100 kilometers per hour. So, when we're looking at the speed equation, we can rearrange it. And I can either rearrange it first or rearrange it after. Plug my numbers in. So I know I'm looking for distance. So I want to get distance by itself. Right now it's in a fraction. Since time is at the bottom of the fraction, I can multiply. Actually, let me redraw this out so it's better. So, I don't want that. Okay, speed equals distance over time. Okay, so you can see time's at the bottom of the fraction. So if I multiply by time, which will be like time over 1, but this time, it's actually going to cancel out, but you have to multiply on both sides. It's going to cancel out the time. So that will leave us with distance on one side by itself, and then speed times time. So now I can just plug it in, right? Distance equals 100 kilometers per hour times 6 hours. So remember I said if you're multiplying and the units are on the top, they'll cancel out the units on the bottom. So that's how we know that the distance is in kilometers, because this hours was at the top and this hour is at the bottom. So we're going to end up with 600 kilometers. Yes? If visualizing it like that helps you, crossing out your units and stuff, that certainly has always helped me. But if you just know that distance is going to be in kilometers because of you're looking at the problem and kilometers is in the problem, and it's not asking you in the question to put it in meters or anything like that, then you obviously already know that. But if you would like to visualize it, that's a good way to visualize it. Okay. If you run at 12 meters per second for 15 minutes, how far will you go? So again, we're rearranging our formula that we have. Right? Because we have a speed. This is our speed. And this is our time. And we are looking for distance. So that's why I put distance over here by itself. Okay, so distance equals 12 meters per second times... okay. So we have to do a conversion here. So I'll do that conversion. I'll do it over here. I have space. So if you want to do your conversions like this, 2 minutes for one. So for every minute, we have 60 seconds. So I have 60 seconds over 1 minute, and that's going to cancel out my minutes. And I'm going to end up with 900 seconds. I could have also converted my meters per second into meters per minute. I felt that was appropriate. So 12 meters per second times 900 seconds. $1,800 meters. Because remember, this is on the top, this seconds is on the top, this seconds is on the bottom. So they're going to cancel out. So we're going to end up with just 10,800 meters in 15 minutes. It's not too bad. Okay. Where's this? Hopefully you guys understand converting units pretty well. Being able to convert like a fractional unit is going to be a skill that you need as well. Number 5. Every summer I drive to Pennsylvania. It is 895 kilometers to get there. If I average 100 kilometers per hour, how much time will I spend driving? So we're looking for time. We know our speed is 100 kilometers per hour. And our distance is 895 kilometers. Doesn't look like I have to do any conversions. It's not asking me to change it to minutes. And I have kilometers in both things. So that works out well. Okay, so I'm going to just plug stuff into the speed equation and then we'll move stuff around. How about that? So my speed, 100 kilometers per hour. Actually, we need to write this. 100 kilometers per hour. That's 1 hour, right? Just don't write that out. Distance, 895 kilometers per t second. Nope, we're not doing seconds. We are doing hours. T being what we're looking for, right? So I can multiply both sides by my t. And then to get the t by itself, I would have to divide both sides by 100. So plugging the numbers in first before you change your equation around is going to make things look a little more complicated. But that's that. Bullet travels 850 meters per second. How long would it take a bullet to go 1 kilometer? How long will it take? So I know I'm looking for time again. My speed is 850 meters per second. And my distance is 1 kilometer. So look again, I have to convert this. So I know that 1 kilometer is 1,000 meters. And that's how you do your conversion for other numbers, is using 1,000 meters per 1 kilometer. Since it was already 1, I don't have to do any math. I already know that. Okay, so let's rearrange this equation. Speed equals distance over time. I need to get time by itself, so real quick, just multiply both sides by t. So then I have distance equals speed times time. Speed times time. To get rid of the speed, I have to divide it on both sides. So time equals distance divided by speed. So they essentially switch places there. Okay. So now I can plug it in. So time equals 1,000 meters divided by 850 meters per second. We're going to get 1 point. I'm going to round it up to 1.8. It was 1.176. So I'm going to round it up to 1.18 seconds. Okay, last three problems. Here we go. Every winter, I fly the 1,544 kilometers home to Chicago. It takes 3 hours. What is my average speed? So I'm looking for speed. I know my time. That's 3 hours. And my distance, 1,544 kilometers. So easy peasy. We just plug it into our equation. Speed equals distance over time. This is our units. This is our answer. Okay? So I get 514.67 kilometers per hour. Traveling 514.67 kilometers every hour. Fastest train in the world moves 500 kilometers per hour. How far will it go in 3 hours? So we're almost looking at the same problem. So, except we're looking for distance. Right? So, looking for distance. We know our speed is 500. We know our time is 3 hours. Remember, after we rearrange the speed equation, it's distance equals speed times time. So 500 100 will it take light moving at 300,000 kilometers per second to reach us from the sun? The sun is 15 million kilometers from Earth. So how long will it take? So we're looking for time. You know the distance, 15 mil. And we know the speed, which is 300,000 kilometers per second. Remember, we rearranged the speed formula over here to get time equals distance divided by speed. Pretty much switch places because it was speed equals distance over time. Now it's time equals distance over speed. So seconds. Okay. I hope that was helpful to you guys. Remember to always write your units and draw visuals. And I will see you for the next one.